So in this tutorial I'm going to talk about symbols and how we can use them to not have to think too much about what's connected to each pin, and I'm going to talk about the debug command and the help command. So instead of remembering that the enable pin for the right wheel is C5, I'm just going to say symbol right wheel enable equals C5. So in my main program, instead of writing I C5 and remembering that C5 will be C, and remembering that C5 is the enable pin, I can write hi right wheel enable, which just makes it a little bit quicker. Now I'll talk about the debug command, and I'll talk about the two sensors, the light sensors LDR1 and LDR2. So this is LDR1, LDR2, and this is pin B6, and this is 5 volts and ground. And if I have light shining on this one, there's the resistor decreases in resistance, and the voltage on pin B6 goes higher and higher towards 5 volts. And if I shine light onto LDR2, the resistance here decreases and the voltage on pin B6 decreases. So I'm going to use the ReadADC command, and if you're ever not sure what to put after ReadADC, just go to help and basic commands, and this gives you a list of all of the commands that the pickaxe knows, and I'll go to ReadADC. So this is telling me that it needs a channel number, and it needs to put whatever value it reads into a variable. So I know that the LDR is connected to pin B6 because here on the pin configuration diagram I've got B6 there, and the LDR light dependent resistor divider network is there. So ReadADC B6, and we'll put that into a variable. Right now I'll just use variable B1. Now the debug command is really nice. I'll just hit F5 to program that in. That's programming. Debug command is really nice because it tells you exactly what's happening with all of the variables in real time. So this is the debug window that's just opened up, and I can see that B1 is hovering around 142, and if I shine a light on the left sensor, that jumps up to about 217, and the left, if I shine it on the left sensor, goes down to 40 odd. So if I want to make a light-seeking robot, right now I would want the right wheel to turn on, the left wheel to turn off, and the robot would move towards the light. So let's see if we can program that in. If B1 is less than, say, 110, then turn left. We haven't told it what turn left means yet. If B1 is greater than, let's say, 125, then turn right. And if it's somewhere in between, the program will just sequentially go to the next line. And I want the robot to go straight. So if I want the robot to go straight, I have to turn on a couple of motors. Right wheel A, C4, low C7, and I'm going to use this. So this enables the right wheel. Might as well take out that debug. And now the left wheel. So if it's less than 110, it'll turn left. If it's greater than 125, the program will jump to turn right. I haven't defined that yet. And if B1 is somewhere in between, then the light should be coming from straight ahead, and these motors will just turn on and it'll go straight. So turn left. What do we do? Let's say the motors are both going straight at the moment. To turn left, we're going to turn off the left motor. So we're going to disable the left motor. So we say low, left wheel enable, and go to main. So that will turn off the left wheel, the right wheel will continue on, and the robot will turn left. Now I have to tell it what turn right means because it doesn't know. Yeah, it looks good to me, and that's a very simple program to make a light-seeking robot. You might have to change some of these variables depending on how sensitive you want it to be. And what you can also do is limit the amount of turning by adding delays. So for instance, I can just put in a pause 100 there, just to make sure that it turns left for a long enough period of time to make the turn. In general, you probably don't need that. Thanks for watching.